Hey guys, in this video we are going to solve the question number 49, which is group anagrams. This is very similar to the other question which you did, and that was to find whether two strings are anagrams or not. And in this case, we have got a list of strings, and we need to just group them as sublists or a list of lists where each list contains anagrams. So coming to the brute force method, it's quite simple. So first we define an answer dict, or here default dict called ans, and then for each element or for each string in the list, we basically create a key, which is a sorted version of the string. So for example, so sorted of as, for example, if we have this example, right? So let me just copy it. So strs is equal to eat t and and nat. So what happens is, in the first iteration we uh, iterate over the string eat, and if we sort it, so it would become aet, and so this aet, right? So we basically create a key out of this. So now key would be aet, and in our answer dictionary, right? So if you have the answer dictionary here, so key of, or let me put it in the way. So answer of key is basically answer of aet, uh, would be stored, or rather would be appended with the string that we have, which is eat. So in this case, the answer dict would look like aet eat as a list. Okay, so now when we come to the next string, right? So it's tea. So again, the same thing happens. So sort tea would give us aet again, and then what we do is, again in the similar way we do ans of key is equal to ans of aet, and we append, so we append the string that we are currently parsing to this ans of aet. So the string is tea. In this case, our answer uh, dictionary would look like aet, and then since we're appending to the existing list, so our existing list had eat, so eat eat, this would become teat. Okay, so I mean this process continues, and finally we get our answer. So the only problem with this is the time complexity. Worst case would be m into n log n, because basically it's very easy to see. So log n is for sorting, and if we have a max of max length of str as n, so we'll take n log n time for sorting each string, and this is the number of strings in our array. So this is the time complexity, and our space complexity similarly um, would be like basically the number of words that are in the uh, particular like particular strs list that we have. So if we take that to be O of m like we did here, so the space complexity would be O of m. Okay, so this is how we go about solving in the brute force way. Now let us just try to optimize this and see where it goes. Okay, so coming to the optimized method, let me just write the array that took again. So str is EATTA, TN, and AT. Okay, so str is TN and AT. And AT. So the first step, obviously, we have to iterate over all the uh, strings. So let's keep this for s in strs. So we do this. So we'll have to iterate over all the strings. And once we do this, right, so the trick here is that we'll keep a count uh, array, which is initially it has 26 elements for each of the 26 letters in the alphabet, and it basically keeps the count of uh, the letters which are there in S. So that's the whole idea behind this, and it gets reinitialized every time for every S in STRS. So after we do this count, we are basically going to find the ASCII value of our uh, first letter. So f- let me just explain what ASCII is here. Uh, so if you take this letter string as EAT, right? So the ASCII of E uh, would would basically be the ASCII of A plus 4. So A, B, C, D, E, yeah. ASCII of A plus 4. So the ASCII of A, which defined in Unicode, is basically 97 plus 4 would make it. So this would be 101. Okay, so uh, this would be the ASCII of the letter E. So now, since we have 26 places in our count, right? So let us do one thing. I will show you how we map the index in count to the letter. So let's just consider A, B, C, D, E, F, for example, right? So now basically this would be 97, 98, 99, 100, 101, 102. So this is the ASCII value, and the index would be uh, 0, 1, 2, 3, 4, and 5. So if you can carefully observe, right? So the ASCII value of E minus the ASCII value of A, so would basically give us the index where we have to store the frequency for E. So basically what that means is our count of so so, so for every character in S, which is our particular string at an index, so count of ASCII of C minus ASCII of A would, we just need to increment it by 1, as you can see, right? So if, for example, if you have an A itself, right? So I mean, in the next iteration here, we would get an A as the character. So if we have an A itself, so the ASCII of A would be 97. So let's say ASCII of A here is 97, and I mean the ASCII of A, which is, which we are mapping to our uh, or which are mapping in our count, is also 97. So 97 minus 97 over here. So if we have A here, so 97 minus 97, basically the ASCII value of our character minus ASCII value of A, which shows us where to store our frequency for the letter in count, would be 0. So count of 0 would then be incremented to 1. So the array at this stage would look something like, A, B, C, D, E, F, dot, dot, dot. So this goes to 26. So it will look something like 1, 0, 0, 0, 1, dot, dot, dot. Okay. So this is how it would look. And once we have this right, so the whole idea is we convert this count in the same for loop to a tuple, and then we just make it a tuple of count, because in Python we can't use a list as a key, so we make it as a tuple, and then we uh, basically answer of tuple of count, we use it as a key for an answer hash map, and then append our string s. So, well, the idea is that we completely skip sorting over here. We don't sort it. Rather, we just keep an array or a list which stores the frequencies of each of the strings. So I mean, um, so let's say the next iteration, right? So for SNSTRS, we go to T. So let's see what happens for T, right? If you follow the same method, which you can iterate it over. So if you follow the same method, right? So your count array f dot 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 at this rate. So let's say we have a T here. So your count array would look like there's a 1 here, there's a 1 here, and there's a 1 here. So all the others are basically zeros. And this count array, right? So it matches the count array for the previous word, in which in our case was eat. So if we have a T here, right? So it'll be a 1. So if you keep iterating over the characters and find that we can store the frequency for T also in the count array in the same way, we can observe that this array matches this array. So essentially, when we repeat this step, right? So when we convert this into a tuple, uh, we basically store the T word in the same key as we stored it. So I mean, to make it easier, at after iterating over it, so our ans would look something like eat. No, sorry. So our ans would look something like so 1 comma 0 0 0 1 dot dot dot, and this is a 1 for um, t, and then we would have eat here. Okay, and after t. So since we get the same count, right? So we get the same count list as eat. So now the answer would be 1 eat. This is for t. Then here, since we are appending, so we eat comma t. Okay, so this is how the whole idea is. So I mean, in if you have like uh let me just search for it. Okay, if you have tan, right, so the same process occurs again. So in this case we would get a different count array, and then we use it as a key and append tan to it. In case of nat, we get the same count array as tan because the words and the letters and the frequency are the same. So we append it to the same key as tan. I hope it's clear. So the time complexity for this would be we go of m into n times 26. Okay, so uh, okay, just give me a minute. Yeah, so the space complexity, I'm sorry, would be m into n times of 26, whereas the time complexity would be uh, m times n because we are iterating over each of the uh, strings, and if there are m characters in each string, right, or in let us make it more simple. So if you have n characters in each string, we are iterating over each of the strings. So if you have m strings, then the time complexity would be m into n since there's no sorting, whereas the space complexity would be m into n times 26 because our count array is static, which is uh, 26 in this case, but then we have uh, m words or m strings with n letters each. So in that case, the space complexity would increase m into n times of 26. So moving on to the code. So the code is quite simple. So as I explained, we define an answer dictionary, and then for each of the strings in S, we keep a count list which has 26 which has 26 elements, and at first each of them is a zero, and then for each character in rs, we calculate the uh, ASCII value using the ord function or factory function in Python. And then after we have traversed to each of the characters in the string, we append it to our default dict, and then we print answer, or rather we print answer out values because we just need the words, right? So we print answer out values. So if I check the submissions, I mean it's a quite decent. So sometimes Leetcode doesn't show the exact uh, runtime analysis. So but this is the most optimized solution that we can get. And yeah, that's all for this video. Thanks for watching.